I love this question that was asked in the trigonometry section. Anytime you have the composition of a trig and inverse trig function like this, excellent question. So the key to doing questions like this is to remember that all inverse trig functions are merely an angle. So it's easy and accurate to go ahead and let theta represent that angle. The final answer to my question will be whatever the sine of theta is, where theta is going to represent the inverse cosine of x over 2. Now, if theta is representing the inverse cosine of x over 2, that means I could take the cosine of both sides of this equation and get that the cosine of theta is x over 2. Now, at that point, this tells me some information about theta. I know that the definition of theta within a right triangle is that it's the ratio of the adjacent side divided by the hypotenuse. So if I draw a right triangle here and I label this angle theta, then I can say the adjacent side to theta is x, the hypotenuse is 2. And then the other leg is always the square root of the hypotenuse squared, 4 in this case, minus the other leg squared. So I'll get the square root of 4 minus x squared there. Now, the final answer to the question, I use this to answer, and I just say, well, I'm supposed to answer what the sine of theta is to get to the final answer. Well, sine of theta is the opposite over the hypotenuse, and so we would get our square root of 4 minus x squared all divided by 2. And that would be our nice final answer there. And it looks like that's the same answer Pearson was wanting over here too. But this is how you get to it. Excellent question. You should expect to see something like this question on a test. Very good one.